Hello, my dear students. In this video, we will be dealing with first, notations, and second, the different properties of sum. So at the end of this video, you are expected to know the different properties of sums and expand and evaluate the summation of given variables by applying the different properties of sums. Have you seen notations or equations or expressions like this? Where have you seen them? You're right. These were commonly seen or used in algebra or in statistics. So, statistics, as used in many researches, often requires familiarity with the mathematical shorthand used to express measures in statistics because as you can observe in these three expressions, they are complicated and long formulas. So in statistical computations, a simplified system of notation is required to avoid complicated and long formulas like this that describes mathematical operations. The addition operation alone plays an important role in the study of statistics. So we need to express sums into compact and simple forms. These call for the need to ask to understand summation notation. Let's now start with notations. When we say standard notation, these are symbols used to express numerical ideas, minimizing excessive use of words or variables. So these are simplified system of notation to avoid the complicated and the long formulas that we usually use. But this time, we will work with the sum. So we have here a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus up to a sub n, or the sum of the first up to the nth value of a. Now, the most convenient shorthand notation for sum like this involves the summation notation. And what is this summation notation? It is also known as the sigma notation, which represents a series of sums in a compact form. We have here the formula for a summation notation. This is read as summation of x sub I, where I ranges from 1 to n. This E-like symbol here, this is called the summation sign or symbol. So when we say summation, it's the sum of. So it involves the operation addition. And the variable placed beneath or below the summation symbol, which is usually denoted by small letter I. Sometimes we use X, J, T, and any other letter. Is the index of summation. This is the variable being summed. And the number here equal to the index of summation is the starting point. What number are you going to start? And the letter or number above the summation symbol is the stopping point. It determines where are we going to end our summation. That's the stopping point. And to the right of the summation symbol is this x sub I, which is the typical element of the sequence being added. So this represents what we're going to add, and This represents where will we start and where will we end. Let us have examples. Compute the sum. First, summation of I where I ranges from 1 to 4. So if we're going to solve for that, take note, we are adding the values of I starting from 1 to 4. So we have 1 plus 2 plus 3 plus 4 and the sum is 10. Another example, summation of x where x ranges from 3 to 7. So we have to add the numbers 3 to 7. Adding those numbers, we have 25. Now, if the summation is certain that the sum is taken for all the values of the variable from 1 to n, then it is convenient for us to drop the subscripts and remove the starting point and stopping point. So we now have summation of x. So this implies that we have to add all available values of x. Next, we have the different properties of sums. We have 7. Starting off with the sum of the product of a constant and a variable. It is equal to the constant multiplied to the sum of the variables. In symbol, we have summation of cx sub I, where I ranges from 1 to n, or we can have C times the summation of x sub I, where I ranges from 1 to n. So there are two ways on how to evaluate the sum of the product of a constant and a variable. The capital letter C here represents a constant. So we have a number, a multiplier. Let us have examples. Evaluate the given summation notation. First, summation of 5i where I ranges from 1 to 5. So first, we have to expand the values. So that's 5 times the starting point, which is 1, plus up to 5 times the stopping point, which is 5. Multiplying those numbers, we have 5 plus 10 plus 15 plus 20 plus 25. So we have 75. Aside from that, we can also use this solution. We have here the constant multiplied to the summation notation. But on the summation notation, we do not have here now the constant because we had written it before the summation notation. Now, if we're going to expand this one, we have 5, that's the constant or the multiplier, times the sum of the numbers 1 to 5. So we have 5 times 15, and that is 75. So as you can see, we have same answers. Now you can use any of these two. Another example, summation of 3m where m ranges from 6 to 8. So we have 3 times the values for m. We have 6, 7, and 8. Multiplying those numbers, we have 18 plus 21 plus 24, and that gives us 63. Or you can use the other solution. We have 3 times the summation notation m, where m ranges from 6 to 8. In this solution, we have 3 times the sum of the numbers 6 to 8. So that's 3 times 21, so we have 63. Let us have other examples. But this time, we're going to use the data given on a table to expand and evaluate. When we say expand, you do not have to solve. You just have to write the given summation notation into an expanded addition or long addition. But when we say evaluate, you have to solve, compute, or find the value. That means your answer for evaluate is a number. So let us have example number 3. 7 times the summation of x sub I, where I ranges from 4 to 6. So in here, we have x sub I column and I column. So if we want to look for x sub 1, that is 5. X sub 2 is 3. X sub 4 is 8. X sub 7 is 6. But before we substitute, we have to expand first the given summation notation. So we have 7, the constant multiplier, times the sum of x sub the starting point, which is 4, plus x sub 5 plus x sub the stopping point, which is 6. So we have to substitute now. That's 7 times 46, that's 8, 10, and 2. Adding those three numbers, we have 7 times 20, and that is 140. Another example, summation of 4x sub I, where I ranges from 1 to 6. So this time, the number is written as a typical element together with x sub I. So when we expand, we have 4 times x sub 1 plus 4 times x sub 2 plus up to 4 times x sub 6. So by substitution, we now have 4 times x sub 1 is 5, then 4 times 3, then 4 times 4 times 4, 4 times 8, then 4 times 10, then 4 times 2. So we have 20 plus 12 plus 16 plus 32 plus 40 plus 8, and that is 128. So that's all for the first property. Next, we have the sum of a constant. Take note, when we say constant, it's a number. It is equal to the constant added n times by itself. So we have here summation of c sub I, where I ranges from 1 to n. So when we expand this one, it is equal to c sub 1 plus c sub 2 up to c sub n. But since we do not have here a variable, when you solve for this, the constant will remain. Example, evaluate summation of 2 where I ranges from 1 to 8. Take note, on our typical element, we only have here a number. So whatever the value of I here, that number will not change. So we have 2 added 8 times by itself. So that's 2 plus 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 2. Why? Because if we have I equals 1, that's 2. I equals 2, I equals 3, 4, 5, 6, 7, 8. So adding those numbers, we have 16. Another example, summation of 12 where m ranges from 11 to 14. So we have, if m equals 11, 12, 13, and 14, so there are 4 12s, and that is equal to 48. Next property, we have the summation of a sum. It is equal to the sum of the terms taken separately. Formula, we have summation of x sub I plus y sub I, where I ranges from 1 to n. Or we can separate those two variables and make each a summation before adding. So we have summation of x sub I, where I ranges from 1 to n, plus summation of y sub I, where I ranges from 1 to n. So if we're going to expand the first formula here, we have summation of x sub 1 plus y sub 1 plus x sub 2 plus y sub 2 plus x sub 3 plus y sub 3 up to x sub n plus y sub n. Let us have an example. Let us have examples. Use the given data on the table to expand and evaluate. First, summation of x sub I plus y sub I, where I ranges from 1 to 3. So we have the first pair, that is if I equals 1, x sub 1 plus y sub 1. And then x sub 2 plus y sub 2 plus x sub 3 plus y sub 3, because we only have 3 values for I, that's 1, 2, 3. So this is now the expanded form. Now if we substitute, we have x sub 1, y sub 1, we have 5 and 3, then 3 plus 6, then 4 plus 8. So we have 8 plus 9 plus 12, and that is 29. Another example, another solution. We have here the separated summation for each variable. So for the variable x sub I, we have x sub 1 plus x sub 2 plus x sub 3. And for y sub I, we have y sub 1 plus y sub 2 plus y sub 3. By substitution, we have to add 5, 3, and 4 plus 3, 6, and 8. So that's 12 plus 17. So still we have 29. Another example. Summation of x sub I plus y sub I, where I ranges from 4 to 8. So again, we have to expand that one. So we have x sub 4 plus y sub 4 plus x sub 5 plus y sub 5 up to x sub 8 plus y sub 8. So we have, so by substitution, we have 8 plus 3, 10 plus 4, 2 plus 1, 6 plus 7, and 4 plus 11. Adding each pair, we now have 11 plus 14 plus 3 plus 13 plus 15, that is 56. Next property, we have the summation of a variable and a constant. So it's equal to the sum of the variables added to the product of n and the constant. There are two possible ways on how to evaluate this property. First is to have the summation of x sub I plus the constant, where I ranges from 1 to n. And second, we have summation of x sub I plus nc, where I ranges from 1 to n. Take note, the small letter n here does not necessarily mean that we copy the stopping point of the summation notation. This represents the number of values considered from the starting point up to the stopping point. You can copy the stopping point if and only if the starting point is 1. Let us have examples. Evaluate x sub I plus 7, where I ranges from 1 to 4. So we have the sum of 7 and the values of x sub I. So that's 1 plus 7 plus 2 plus 7 up to 4 plus 7. Adding those numbers, we have 8 plus 9 plus 10 plus 11, and that gives us 38. Another solution, we can have summation of x sub I plus 7n, where I ranges from 1 to 4. So this time, we have to get first the summation of x sub I. And that's 1 plus 2 plus 3 plus 4 plus the product of 7 times 4. Since we have a starting point of 1, we can use the stopping point, which is 4. So that's 10 plus 28, and it's 38. Another example, summation of x of I plus 3, where I ranges from 7 to 11. So we have 7 plus 3 up to 11 plus 3. So getting the sum, we have 60. Another solution for that is getting first the summation of x of I, where I ranges from 7 to 11 before adding it to 3 times the number of values. So that's 7 plus 8 plus 9 plus 10 plus 11 plus 3 times. If we're going to count the numbers from 7 to 11, we have 7, 8, 9, 10, 11. There are 5s. Therefore, we multiply the constant 3 to 5. So that's 45 plus 15, and again, it's 60. Let us have other examples using a table. So in here, we have to find for the summation of x of I plus 9, where I ranges from 1 to 3. First, we have to expand the given summation notation, and that gives us x of 1 plus 9 plus x of 2 plus 9 plus x of 3 plus 9. So there are 3 sum like this form because we have 1, 2, 3. And then by substitution, we have x of 1, that's 5, x of 2 is 3, and x of 3 is 4. Adding those numbers by 9, we now have 14 plus 12 plus 13, and that is 39. Another example, we have summation of x of I plus 8, where I ranges from 4 to 7. So again, we have to expand. That's x sub 4, because that's our starting point, plus 8, plus x sub 5 plus 8, up to x sub 7 plus 8. By substitution, we have for x sub 4, that's 8, x sub 5 is 10, x sub 6 is 2, and x sub 7 is 6. Adding those values of x sub I by 8, we now have 16 plus 18 plus 10 plus 14, and that is 58. That's all for the fourth property. Next, we have the fifth property, the sum of the squares of the variables. It is equal to the sum of the squares of the given variables. In symbols, we have summation of the square of x sub I, where I ranges from 1 to n. So to expand that, we simply have to copy the typical element, but we're going to substitute the i's using the starting up to the stopping point. So we have the square of x sub 1 plus the square of x sub 2 up to the square of x sub n. Let us have examples. Evaluate the summation of I squared, where I ranges from 1 to 5. So to solve for that, we have 1 squared plus 2 squared up to 5 squared. And that gives us 1 plus 4 plus 9 plus 16 plus 25, and that's 55. Second example, evaluate the summation of I squared, where I ranges from 9 to 11. So we have 9 squared plus 10 squared plus 11 squared, and that gives us 302. Let us have examples using the given data on a table. First, evaluate and expand summation of x sub I squared, where I ranges from 1 to 5. Take note, we have to expand first. Therefore, we have the square of x sub 1 plus the square of x sub 2 up to the square of x sub 5. Therefore, we have, by substitution, 5 squared plus 3 squared plus 4 squared plus 8 squared plus 10 squared. And that is equal to 25 plus 9 plus 16 plus 64 plus 100, which is 214. Next example. Summation of x sub I squared, where I ranges from 4 to 6. So first, we have to expand. That's square of x sub 4 plus square of x sub 5 plus square of x sub 6. By substitution, from x sub 4, we have 8, x sub 5 is 10, x sub 6 is 2. Squaring those numbers, we have 64 plus 100 plus 4, and that is equal to 168. Next property, we have the squares of the sum of variables. It is taken by squaring the sum of the given variables. So we have the square of the summation of x sub I, where I ranges from 1 to n. Take note, in this property, we have to add first before we square. The previous property is taken by squaring each value of x sub I before adding. Let us have examples. Evaluate the square of the summation of I, where I ranges from 1 to 5. So we have the square of the sum of numbers 1 to 5. Adding those numbers, that's 15 squared is 225. Another example, the square of the summation of I, where I ranges from 9 to 11. So we have to square the sum of 9, 10, and 11. And that's 30 squared. So we have 900. Let us have examples using the given data on a table. First, the square of the summation of x sub I, where I ranges from 1 to 5. So first, we have to expand the given summation notation. That's x sub 1 plus x sub 2 plus x sub 3 plus x sub 4 plus x sub 5, the quantity square. Take note, we are just copying this one and changing the index of summation by the given values from the starting point up to the stopping point. Now, by substitution, we have 5 plus 3 plus 4 plus 8 plus 10. That is 30 squared. So, we have 900. Another example. Square of the summation of x sub I, where I ranges from 4 to 7. Expanding the given summation notation, we have the square of the sum of x sub 4 up to x sub 7. Now, by substitution, we have 8 plus 10 plus 2 plus 6, and that is 26 squared. So, we have 676. Now, let's have the last property of sum, the sum of a product. It's equal to the product of the terms. It's equal to the product of the terms taken separately. In symbols, we have summation of x sub I times y sub I, where I ranges from 1 to n. Expanding the given summation notation, we have x sub 1 times y sub 1 plus x sub 2 times y sub 2 plus x sub 3 times y sub 3 up to x sub n plus y sub n. Let us have examples. Use the given data on the table to expand and evaluate. First, summation of x sub I times y sub I, where I ranges from 1 to 3. Expanding the given summation notation, we have x sub 1 times y sub 1 plus x sub 2 times y sub 2 plus x sub 3 times y sub 3. By substitution, we have 5 times 3 plus 3 times 6 plus 4 times 8. That is equal to 15 plus 18 plus 32, and that is 65. Another example, summation of x sub I times y sub I, where I ranges from 4 to 7. Expanding the given summation notation, we have to substitute the numbers 4 to 7 on the index of summation. So we have x sub 4 times y sub 4 plus up to x sub 7 times y sub 7. By substitution, we have 8 times 3 plus 10 times 4 plus 2 times 1 plus 6 times 7. So we have 24 plus 40 plus 2 plus 42. So we have 108. So those are the different properties of sum. But before we end this video, remember that annotation is used to simplify and avoid complicated and long formulas in statistical computations. And there are 7 properties of sums. First is the sum of the product of a constant and a variable. Second, sum of a constant. Third, summation of a sum. Fourth, summation of a variable and a constant. Fifth, summation of the squares of variables. Sixth, square of the sum of variables. And last, the sum of a product. That ends our video lesson. And that ends our tutorial video. Happy learning everyone, and thank you for watching.